Hello students, welcome to EPG Pathshala. I am Dr. Ayushi Paliwal from Deshbandhu College, University of Delhi. Today we are going to discuss about the module Materials and Functionality, a Historical Perspective from the paper Functional Materials. Main points which will be covered in this module are: first, importance of functional materials and their classification will be discussed. Second, a broad definition of functional materials. Third, a historical perspective or evolution of materials will be discussed in detail. Fourth, application domains of functional materials. Next, a brief review of structure and bonding in materials will be discussed in this module. Lastly, we will review the planes, directions, and Miller indices. So, students, let us start with a brief introduction about functional materials. Materials such as stone, metals, ceramics, and polymers have played a very important role in the progress of mankind, and their evolution has marked significant steps in the sustenance and transition of civilizations. From an engineering perspective, we define functional materials according to the specific functional property possessed by them, and then design and choose appropriate materials which fits the criterion of that specific functionality. Historical perspective of materials. Materials have played a key role in the development of mankind. Early man lives its life as a hunter, and to sustain itself, it was dependent on hunting of animals for which it needed tools. In the absence of modern weaponry to which we have access to, man had to depend on stone and wood. What was the reason behind it? Because stone are naturally occurring. Some of them are very hard and can be converted into pointed, sharp objects, which can be useful as a weapon. Similarly, use of wood allowed early man to develop pointed but light objects such as spears, as well as use the wood for burning as well as building shelter. As we know from our history lessons, this early age of mankind was called as Stone Age, and the materials in that age were primarily stone and wood based on availability. Subsequent evolution after 20,000 BC or so paved the way for the development of materials such as gold, copper, silver, tin, and bronze, marked by tremendous developments in the metallurgy. Humans found the ways to extract these metals from the ores and This development was very much dependent on the availability of raw material as well as any trade linkages with the neighboring civilizations. For example, resident of Indus Valley civilization developed various jewelry items made of bronze, copper, and gold. The most famous of them being the statue of a dancing girl made of bronze. At the same time, there were significant developments in the use of ceramic materials such as pottery, for example. Many vessels discovered from the ruins Indus Valley civilization between 6000 BC to 1500 BC proved the development of clay pottery. Similar objects have also been excavated from other parts of the world, such as Middle East and Egypt, then part of Mesopotamian civilization, and Europe. Historical perspective from 1500 BC to 1600 AD. This era further gave way to one of the most important points in the human civilization, that is, Iron Age, starting at around 1500 BC. This era paved the way towards the development of most important engineer material mankind has seen, called as steel. Earlier developments of Iron Age took place sporadically in various parts of the world, and India played a major role in those developments. One of the finest examples of Iron Age is Iron Pillar, currently located in Delhi, which has stood the test of time since 4th century CE. Although earlier forms of iron were high in carbon and other impurities, the advances in iron metallurgy gave rise to a much more useful form called as steel. Although steel making goes back to 1800 BC, in Anatolia, high quality steel such as Wood's steel and Damascus steel began to be produced in South India at around 300 to 400 BC. Steel has played very important role in livelihood of people across the world and was used quite heavily as war material in the form of swords, spears, etc. The first step in modern steel making was taken in Europe in 17th century when smelting of iron ore into pig iron was carried out in a blast furnace. Earlier methods primarily used charcoal to reduce the iron ore, which was later replaced by coke in modern blast furnaces. This leads to the production of higher quality and cheaper pig iron. The pig iron contained very high carbon content, often more than 4 weight percentage, and other impurities such as silicon, phosphorus, etc., and hence was not a very useful material. The pig iron to steel conversion was first initiated by Henry Bessemer in England in 1855, where air was blown through molten iron to convert it into steel with much lower concentrations of carbon. Air was further replaced by oxygen by Linz Dowitz of Austria in 1950s, leading to the production of steel with much improved quality and at a lower cost, and hence the process is now called as ALD process. Steel has evolved as the most used material in the history of mankind, which was synthesized by the humans and is used in a wide variety of applications. Historical perspective from 1600 AD onwards. Since 1700 onwards, after Industrial Revolution and Renaissance in Western science, due to advances in chemistry, many more metals were synthesized from their ores such as nickel, platinum, manganese, aluminium, zinc, titanium, magnesium, etc. Among these, aluminium and titanium have paved the way for lighter metals with high enough strength to enable their use in variety of lightweight applications ranging from aerospace industry, automotive industry, etc. Another important material which constitutes a very significant part of modern world is polymer, which is a lightweight material, can be easily deformed and fabricated, and is an insulator. Although natural rubber has existed since long times, its scientific properties were first realized by Frenchman Charles Marie de la Condamine in 1736. Subsequently, first synthetic rubber, a polymer of isoprene, was invented in 1879 by another Frenchman, Gustave Bourgadat, from 1842 to 1918. Over time, several forms of polymers have come into the existence with a wide range of properties such as polyethylene, polystyrene, polyvinyl chloride, etc. Last century also saw the development of other materials such as semiconductors, with silicon being the most important one. Ceramics of various types such as glasses, oxides, carbides, nitrides, which are hard and brittle materials but with exotic electronic, optical, and magnetic properties. All of these materials have played vital role in the development of technologies that we see around us today, whether it is in consumer electronic items such as television, phones, computers, or transportation sector such as cars, aeroplanes, ships, or telecom sector or healthcare. Materials have played a key role in improving life standards, reducing mortality, improved healthcare, etc., via development of technologies that employ them. However, a flip side has been severe environmental degradation by burning of unprecedented quantities of coal, mining for ores to extract metals, contamination of land and water by toxic elements, waste in the form of non biodegradable materials such as plastic, etc. Hence, today a huge challenge lies in front of us to innovate and explore methods and develop materials which do not cause harm to the environment and our future generations. Evolution of materials. Students, now the question arises in our mind, what has driven the evolution of these materials? The most obvious answer seems to be that the evolution of materials has been need based. The needs defined the required functionalities which led to explorations. However, in the modern world, we also tend to explore materials based on specific functional aspects, and then we design applications which are conceived later. It is a back and forth kind of approach which has worked well thus far. Based on improved understanding of materials, we are now able to classify them into categories such as metals, ceramics, glasses, polymers, and composites. The figure below aptly summarizes the evolution of materials in a different scheme of classification, that is, by their characteristics, in the forms of metals, ceramics, polymers, etc., versus their importance. In this figure, one can see that in the early part of human existence, the important materials were stone and wood. This was because these were naturally occurring and they provided the functionality then at that time the mankind needed. Wood is a naturally occurring fibrous material which is easy to cut, is light, can bend and flex, and can be easily burned. So it provided an ideal solution to make shelter, to generate energy in the form of heat for cooking or other purposes, and to make weapons such as spears. Stones are hard and hence they acted as tools, primarily for hunting as well as protection. These were also useful for the purpose of making pottery. Then there was a paper whose earlier forms were leaves or straw bricks. Earliest examples of metals excavated are gold, copper, bronze, and tin. Gold was primarily used for ornamental purpose due to its yellow luster, which attracted humans. It was possibly used as currency too in later times. Subsequently, copper, bronze, and tin also served the same purpose but were more extensively used as these were probably more widely available than gold ore and were easier to melt, mix with the other elements and fabricate. Presence of jewelry and other artifacts of these suggested that primary use of these metals was for decorative purposes. These metals could also have been used for making tools for agriculture in the Bronze Age. Development of fire from the previous era possibly gave rise to rudimentary smelting techniques where humans could form these materials whose essential functions were their ability to be formed into various shapes by the use of force. In this era, possibly metals provided the key attributes such as malleability, strength, environmental stability, and their ability to be polished and formed, which appears evident in the objects discovered from Bronze Ages. Later, these attributes were also exploited in the fabrication of utensils which could withstand high enough temperatures and were perfect for cooking as well as storage. Subsequent evolution of Iron Age really opened the doors into realms of technology, as iron could be hard as well as soft. It could withstand higher temperatures, and just like its predecessors, it could be converted into various shapes with the use of force. Iron's exploits were built on its fantastic properties. It offers high mechanical strength, which increases, and ductility or malleability increases as carbon content decreases. It can be extremely hard as well as moderately soft. It is extremely sensitive to the processing conditions such as heat treatment conditions of time and temperature, allowing it to be tailored appropriately for required applications. Of course, subsequent evolution saw the fabrication of steel, which has lower carbon content and is a far more useful material than previously used high carbon content iron as far as strength and ductility combination is concerned. Later, the mankind learned how to make it environmentally stable by fabricating stainless steel. Its combination with various other elements allowed iron to be formed in the form. As we can see from the figure that the time progressed, utilization of metals and alloys increased with the advances in forming and smelting techniques, aided with the improved knowledge of thermochemistry and thermodynamics of variety of metals. Advent of other metals such as copper, aluminium, nickel, titanium, along with iron, led to a massive reliance of humans on the metals, and this peaked at around 1950s due to large-scale use in structural applications, including automotive sector, bridges, rails, trains, electric cables, ships, etc. Subsequently, it was also realized whilst metals were good for various structural applications, they had a few disadvantages. That is, they were high conductive, providing little insulations. They softened as temperature increases. They were susceptible to corrosion, and they were opaque as well as heavy. With the advances in electronic devices and semiconductors, there were large scale efforts on developing other materials, and the emphasis was on developing synthetic polymers, ceramics, and glasses and composites. This was possible because the scientific understanding of materials, physics, and chemistry was much more advanced than it was before. This is what possibly gave rise to the age of functional materials, because now one could make fanciful materials with amazing properties and then conceive applications which were never thought of before. Advances in the functional materials led to significant properties, or the progress was there in electronic devices, and hence consumer electronics, healthcare products, improved communication, faster transportation, etc. Material development versus functionality. Now let us see the evolution of materials from the perspective of few applications. Main function of a kettle is to heat the water, which requires the use of materials which could conduct the heat well and withstand high temperatures of the flame during boiling. Earlier generation saw the use of metals such as iron, copper, bronze. This changed dramatically in 1928 when an electric kettle was introduced, which consisted of a electric heating element, metal, sealed inside a walled metal tube placed within a chamber made either of metal or plastic. The kettle body was no longer exposed to high temperatures, and hence, from the perspective of electrical insulation, it made sense to use plastic, which is an electrical insulator. Transport sector is again a marvelous example of materials evolution. As you can see from this figure, this figure shows the replica of the ship, that is Santa Maria, used Christopher Columbus in 15th century, primarily made of wood. And in the preceding figure, you can see the passenger ship of Cole Dusseldorfer on the river Rhine in Germany. Earlier generation transport vehicles were typically made of wood, which were carried by animals, and wood needed to be thick to bear the load. Advent of strong iron saw these vehicles getting stronger with much reduced material being used. Advent of strong iron saw these vehicles getting stronger, so this reduces the material to be used in the vehicle. Subsequently, invention of coal engines and steam engines saw the arrival of steel-bodied train cars, which ran on rails made of steel. Similarly, water transport required ships to be made lighter as they need to float. Earlier generation ships used wood, which degraded quickly. Currently, the ships use several types of metals and plastics to give ship a shape so that it can float and yet being highly durable and strong. Advent of electricity has been a major landmark in the human history. Electricity plays a very dominant role in our lives as most appliances that we use on a routine basis uses electricity. Early evolution of electricity applications required the development of the materials which could transport electricity, that is a conductor. This led to the development of materials such as aluminium and copper. Further advancement in physics led to the conception of materials which were different than the metals, that is, semiconductors and insulators, which found applications in diodes, which can act as switches, or capacitors, which don't conduct electricity.
So, students, let us summarize what we have learned from this module. Firstly, whilst earlier development of materials was primarily need-based, advances in science and technology in 1900s have expanded the materials universe several times, as now one can design materials in the laboratory and tailor their properties for intended applications. In fact, modern approach also leads to applications which were not possible earlier, as based on materials' exotic behavior, one can imagine fancy applications. Thank you.